GATE 2020 Civil Engineering Set 1 Question 39. If C represents a line segment between origin and 111 in Cartesian coordinate system, the value of the line integral y plus z into dx plus x plus z into dy plus x plus y into dz needs to be found and expressed as an integer. The relevant NPTEL reference has been listed. If we are given with a function f of x, y, z which needs to be integrated over a line or a curve, that is C. So what we essentially do is we use parametric substitutions and replace x with a function of t, y with a function of t, and z with a function of t. When we do this, what we will get is C will transform to a definite integral from a to b. The function will change from, initially it was a function of x, y and z. Now it will be a function of xt, yt and zt. So xt, yt and zt, and we will multiply this with the summation of d, the variables xi over dt whole square, where I varies from 1 to 3 in this case. Here I will indicate x, y and z, so I is a value of 3. This into dt. So using parametric substitutions we can find the line integral. It can also be done using simple integration principles if the question allows so. In this case we are given the integral, let us say it as I, as from a curve C we need to integrate y plus z dx plus x plus z dy plus x plus y dz. Firstly, we need to integrate it from origin to a point 1, 1, 1. Let us expand this integral. We will get y dx plus z dx plus x dy, z dy, x dz and y dz. We can notice that it has terms such as y dx and x dy, which can be written as d of xy, that is, using the UV rule of differentiation we would get x dy plus y dx. Similarly, for the other terms also we can see pairs such as z dx, x dz, z dy and y dz. So we can pair these terms together. So these two terms will go together, these two terms will go together, and these two terms will go together. So it will become I C. The first two terms will go together, so it will become y dx plus x dy plus second two terms are z dx plus x dz plus y dz plus z dy. This can be written as C d of xy plus d of xz plus d of yz. We know that the integration of a variable dx is given as x. So here we can write the same as xy plus yz plus zx, and we need to substitute the limits from 0, 0, 0 and 1, 1, 1. So when we substitute we would get x and y as 1, y and z are also 1, plus 1, minus we will substitute the lower limit, that is 0, 0, 0, which would give 0 plus 0 plus 0. This would give the value as 3. So in this case, since the integration was very simple and limits were a constant value, using simple integration principles we could compute this line integral with a value of 3. We do not need to use the parameterization principle, but for a complicated question it may be needed. So C was a line segment between origin and 111 in Cartesian coordinate system, and the value of the line integral was obtained as 3. The relevant NPTEL reference has been listed.